All right. So a week ago, we were talking about some of this major design practice or principle you need to know to help you to do a better software design. And we mentioned about the solid principles. That's one set of principles very important. We also mentioned about agile software development approach. For those of you who are in the 4D class, you probably know the agile doing better. It helps you to get more frequent feedback and get feedback earlier so that you can fix the issues. Now, there's one slide we also mentioned about two more other things. One called design pattern, the other one is called refactoring. And both are really important practice you do every single day as a professional software developer. So in the coming weeks, we'll probably need to spend maybe around 1 month to really talk about design patterns. This is a super practical. Okay, you learn something, you can use that right away. And then we'll give you some exercises to do as well by applying the design patterns into your assignment. And then once you start to learn the design pattern, you could definitely see the opportunity to use this design pattern in some other coding projects or other course assignments. All right, but today I will just spend some time to give you some overview about design pattern, what that is, why are we learning that, what the special things about design pattern, what kind of pattern are we going to cover. All right, so today is mostly kind of an introduction. All right, but in the coming weeks, we'll be just covering some of this pattern one by one. All right, and then today's lecture, particularly, I got a lot of slides from Dr. Doug Schmidt. I really want to talk about him a little bit, and you should probably know him. He is professor at Vanderbilt University. I had some of the collaboration with him at different stages of my PhD study, and then also had some research project done a few years ago when I was in Cal Poly Pomona. And then he is really the top, one of the famous guys in software engineering. He's particularly very experienced in software design. And he had a lot of books. And then the most famous book is this thing called a pattern-oriented software architecture. So this book talks about a lot of other patterns, design patterns, for you to build different type of system. For example, what are the patterns you can use to build distributed computing type of system? For example, you build web services. There are certain patterns you can use. What if you want to build some kind of concurrent programming, network programming projects? And there are also certain patterns that can be used in that kind of direction. So this series of books have different volumes, and every volume focuses on one specific domain where you can learn a lot of good patterns and experience. And then this is kind of another kind of famous book on software patterns, but this one came after the most classical kind of forward pattern, the book which I'll talk about briefly. But then anyway, so he is very famous on this field, and then he has a YouTube channel you can find, and then he's uploading quite a lot of YouTube videos and lectures about different kind of things about software design. So very famous. And then recently he's very active in like promoting the online computer science education, just try to get more like recordings, lectures, and topics. So pretty very experienced professor, and also who knows coding really well. So I just want to mention him. I actually borrow a lot of slides from him because he's really the expert on this field, design pattern. All right, so the goal of talking the whole design pattern as well as this whole course is try to change the way you write the code, as I promised in the very beginning. Not sure if you feel any kind of changes, maybe like very slight, minor changes, but hopefully some part of a little coding mindset you had before probably has been involved, and hopefully it's going to be changed in the right direction. So we want you to become basically an expert on designing the software, um, implementing the software, become a good coder, top coder, or we call it like a master, and a professional, really mature master software, engineer. Sometimes we call it a principal engineer. Sometimes nice cool title. So that's our goal of learning all this design. And then, you all know that learning a new language is very easy, but what really matters is how good your code is. And then we all know that the professionals actually write the code totally differently. So that's why, we want to first talk about some of the background. All right. So for different domain, the series are all the same. The principles are the same. Since we're talking about experts, we're talking about the masters. Okay, so I want everyone to kind of set an image in your mind. Okay, what that master look like, and how masters will do things different from amateurs, from beginners. And then you can, don't worry about the coding because you haven't got a chance to see some of the good coders. I had some of this experience with good engineer and good professor at different point in my life. I can see exactly how they do their work, and I can see how they're doing things differently and better than the general developers or beginner developers, including myself. Um, but if you haven't seen that, that's okay. Think about other things you do, hobbies. Think about the sports you like to do or play instrument, anything, right? So I'm sure everyone has one or two, or even you play games, you know how the professional play differently from the non-professionals. I know a lot of you like to watch the YouTube game channels or live streamings about how the some of the professional play. I used to play a lot of CS, so that's why I also like to watch some of those professional players, right? Other things I do, I do spend some time play soccer. I like soccer. Not sure how many of you like soccer as well. I'm not professional at all. Okay, just as kind of hobby. And then I've been playing that for a while. I would say since I would say maybe middle school. Again, nothing professional. I just like to play. But if you since I played that for 10, 20 years, so I'm okay. Okay, if I go to pick up game, I'm okay. I'm average. I would say definitely not the top player, but I can handle very simple like pickup games. But when to the professional games and matches, and then that's a little bit more challenging to me. I'm not like well trained, and then I never had a coach before. I didn't know much, and then there was one time that I remember very clearly. It was back in Tennessee in the summer, and the city organized this kind of international tournament, and I played with a couple of friends, and then they were playing for a university. It's a Tennessee State University. It's a small university, so I was joining their team, and then we played that with some other teams. I remember when they were playing this team. I don't know the name. I don't know where they come from, but they're definitely international, and they come from Africa. We lost really badly, and then after the game, it turned out I learned that there are four guys from the team that they used to play their national like U17, U19, like youth national team for that country. I forgot which country. It's a very small country in Africa. All right, but they're from the national team. So it's really bad, and you basically you feel that you're okay, but when you play with them, they deal with every single thing differently. They run faster, they're more skillful, they're stronger, they got a better strategy, they're fast in terms of response and everything, right? So that's when you start to suddenly realize that the professionals do things quite differently from the beginners. Okay. And then I use that example. I just want you to also think about, some of the fields that you're very into, and then think about the chances you have seen, like some of the top level professional, how they do things differently. That's where we want to go for coding. And same thing. And right now, most of us are actually in the beginner stage. A lot of you are struggling on where to use the interface. A lot of you are struggling on how to get this one method done correctly. Where the professional, the master probably can come up with the whole thing with a perfect, nice, clean code design, within a short period of time. So that's kind of the goal, but we're getting there. But at least you should know that's our goal. Okay, we want to go that direction. We want everyone to become a master and become a professional, and that really looks very cool. And as we're talking about master, okay, so I also want to remind you that there are a lot of masters in different fields, and then they're all doing things very well. And then, but sometimes when we look at these masters, we tend to forget about how much effort they put, right? And also the question, the position. Yeah, I like to play middle field. Not very good, but if it's a game, I have to play the defense. I just the game are too competitive. I can't deal with that, so I have to stay in the back and play defense. That's a little bit easier for me. All right, but again, not professional at all. Okay, just like it. But back to this slide here. Just don't forget about this masters. And I'm sure everyone heard about a lot of stories. Not sure which sports star you like. Any one of this, right? They put so much efforts on it, right? So there's no exception. Speaking of soccer, I don't know how many of you are Ronaldo's fan. Okay, I like Messi much more. Okay, I'm sure a lot of you probably feel the same. I think Messi is more humble. Definitely get more fans. A lot of people don't like him because he's, I think, a little more, arrogant. Sometimes people feel that way. I also think so, right? Anyway, so however, you have to admit that, he is definitely very arrogant. He plays very well. Every time he's very, outspoken, like a very extrovert, but then people don't even think about how much efforts he spent right after the game, before the game, in all the training, all the details. At one point, I read an article talking about he's the only one in the team that every day after lunch, and he actually went back. After the training, they had a lunch. After lunch, most players went back to take a break, and then he actually went back to the field. He would just do a few like free kick practice every single day, and then he was the only one that will do that by himself. So it's like all those details that show that all these masters they definitely put a lot of effort and time on getting to that point. So just while you see their professional, see their accomplishment, just don't forget about that doesn't come within one day. And the key to get there, obviously, you spend time and you put efforts, and then you need to be like repeating things and doing the same thing again and again. That's how you get to be successful. Just like some people saying that you want to be, they use like this 10,000 hours thing, right? So any kind of thing, if you can do that for 10,000 hours, then you will get to a certain like decent level or professional level. There is a very good tech talk from this person, Dr. Joseph. The talk was about confidence, and then he actually is a soccer coach. I remember he's talking about like he's coaching a Canada high school team which won the national championship, and they were talking about picking the right players and how to improve and train the teams. And he particularly mentioned that for soccer as well as for other sports, being skillful is one thing only, but being confident is really important. For those of you who do a lot of competitive sport, you know that, right? So the psychological part, being confident, that actually is really important when it comes to games. You might do really well without pressure, but when you are in a very intense competition, then that's going to mean a lot. So he said that not everyone comes with confidence. Confidence is not born, something that you're born with for most people, right? You have to build the confidence, and you build the confidence by successful experiences, or you build confidence by doing all the things repeatedly. He was giving the examples as the goalkeeper to just kick the ball against the wall and then catch the ball 1,000 times a day. If you can do that every single day, then you will get better, and then for at the same time you will get confidence. If you think about your first assignment, I actually got a lot of questions in those days that you guys were working on assignment, and that you're not sure what to do and not confident if that's right or wrong. But I guarantee that if we do that that kind of assignment for 10 times, different type of assignment for 10 times, you will feel much more different. All right, so that's where you can build a confidence by repetition, by practice. At the same time, you also need to learn from the masters, learn from the coaches, right? So I wouldn't put this one as the top priority, but it is definitely one essential part. At some point, you will need to have coaches to lift you to a different level. I don't think that's important in the beginning. I think in the beginning, it's all about your skills, your foundations, it's your practice, your time and efforts, and all the repetition. But at certain point, you definitely need to have the right coach to give you more help. Okay. Well, again, use a support as an example. I think that's why a lot of these coaches just got so well paid, right? So it worth it. You know, the coach, they bring not just about the training, but a lot more experience. You know, the encouragement to the team and everything. As I mentioned for the soccer, right? I never had the training. I wish I could, join some of this whatever club that is, got some good training, more regular training with coach. I think I probably can do a lot better than what I can do today. I can't play today. I don't have time, and then definitely not fit anymore. So it's a big challenge. But there was one point that I had some interaction with the coach. And that's when I realized, oh, actually, there are certain things that you can learn very quickly, very easily, but it's very effectively from the coaches, even with very small amount of time. There was one time I'd like to really share this one with you. I mean, it's a very simple idea for I'm pretty sure like in our class there are certain some of you are really good at soccer. Okay, this is probably very naive, but even if you don't play soccer, this is something that pretty easy to understand. So, I remember there was this time before the game. It was in from that summer. Okay, so that because the Tennessee State University, they get a coach. It's not a very good coach because the university was very, very small. And then it was just somebody who volunteered to do the coach. And he had some experiences. I think some of the things that he mentioned, makes a lot of sense. He was one point talking about how to do the right defense, how to organize the right defense. And then he was saying that, okay, let's say that you got this, your players, right? So this is your defense position, and then you got four defenders at back, and then you got four in the middle field. All right. And then you got maybe two strikers at the front. Okay. All right. So we're talking about the defense. And then the other side, they come to offense. And then they're talking about how you should organize your defense. Okay, in my mind, okay, I have no professional experience. Now, if you're a defender, wherever you are, if the ball comes to here, if some guy come to here to attack, well, whoever are here, you gotta control your stay in your position, and then just do the best you can to defense, and then to try to do a successful defense. And then in my mind, okay, if they come from this side, then these two guys should be really careful and try your best to cover that. And then the rest will be watching your position, all of this. However, the coach actually mentioned that in general, okay, a better strategy is if somebody coming from this side, all right, now, we should not just stay in the same position. The right way to do is, I'll talk about this when you start to see it makes sense. Now, first of all, when they come in, the defender who are in that side definitely should actually go forward to kind of try to, do a very, very quick response and try to defend that. But then, and the coach suggests that you should like go like really close, try to give enough pressure. Okay, you don't want to like just stay in this area and wait. You should go forward and then do very, very hard and then try to give that pressure in order to get the ball. But if you move too fast to that position, then you're going to lose your position for this area. And then that means that this guy here, you shouldn't stay here. You should actually go cover. And then this guy should move to this guy's position. And this guy should also move to that position, and then this one also will shift. Everybody shifts, just like shifting a read. And also he even said, no, even the defender can actually also go up. Just give more pressure, because when you get two people to tackle one guy, then you got an advantage, so you got a more chance. But then you're gonna lose that position. That's fine. The other defender will shift. Again, do the a read kind of a shifting. all right, to this side, all the way to there. All right. So when I first saw that, well, I said I understand that one, but the issue is that you're gonna have a wide empty area here, right? Because your people are go, and then if somebody are here coming to here side, it's gonna be wide open, then there's gonna be in trouble. But then the coach explained that because number one, now you got more people, more advantage in this one area, so you're more likely to get that ball. You're more likely to get a defense successfully, and then because you give more pressure. And then secondly, even though this one here is wide open, but this is a very far, and they're not going to be able to just get a ball right away to this position, and it's not going to be too like a much threat. Okay, so it's totally fine. So this is, I just want to give you this example that very simple thing, and then you learn that from the coach, and then you just get it right away, and then it can just help you to improve things dramatically. All right. So anyway, I use that example to tell you that there's after a certain level, some of this experiences from the master will become important, from your mentors will become important. But I don't feel that's the most important thing in the first place. In the beginning, if you don't even know the basic skills and everything, telling this one doesn't help at all. All right. So same thing. Again, another better example would be you play all the games, right? So when you see the professional how they deal with the situation, you learn the same thing. I think that's also how you can improve. All right. Um, Also, some of the things I want you to know that knowing programming language is obviously very important, but that's not the most important part in terms of becoming a master developer. All right, and then you can probably easily learn 5 to 10 different programming languages. That's fine, but you might still not a professional. You might still not a master. Your design, your code might not still be clean, right? So just knowing the language itself is not enough. So here is one example. All right, so there is this very interesting competition. Okay, it's called obfuscated C code competition. Right here, you might be able to still find it. Okay, this one here. And then basically this competition asks you to submit really complicated code and very concise, like one-liners. Okay, but it does something really cool and special. So this is the winner program from 2006. Could anyone tell me what this program does? It's a C program. You can guess. You can guess what it does. It kind of hacks the info, right? You're right. What kind of information being hacked here? It's like a one-liner, and it's not really one-liner. You see some semicolons here and here. Yeah, so, but it's very short. Any kind of guesses, hint? No idea? Yeah, something about the time. All right. So if you actually run this code, oh, let me put, yeah, it actually print out the time when this code was compiled, and then in this kind of format. All right. I have no idea how they can do this. I don't even know it's true, but this is the winner. I guess this is the truth. So if you're interested, try to put this code into your C editor compiler and then see what's going on. Yep. All right. But speaking of this code, how do you think about it? How do you like it? Yeah, it's all right, give me 1 second. Right? So it's very frustrating, in my opinion. If you are given this kind of piece of code, then what are you going to do? You think it's very smart, but it's definitely not a good code. Well, that's what we mean here. Just knowing the language very well, the feature, the good function, the APIs, it's good, it's cool. Okay, it means that you're very passionate, you have a lot of interest, but it really doesn't mean anything. Right? So just knowing the language, that's not our goal because it's not the purpose of building the software or good software. Also, we talk about the design, the UML, right? It looks professional, good graphs and visualization, all right. But again, that one, getting a very good document and diagram doesn't really mean anything, okay? Because building the software has nothing to do with, well, not really nothing to do, but doesn't mean that you draw the good UML diagram, you can get the good code. Just like when you build a house and you can draw the house, doesn't mean you can actually build it nicely. All right, you need a lot of practical experience and then do all the single detail correct, right? So really the master developers and professional developers, the reason they become master because they got more design experiences for the same kind of thing being given, and then they know how to build it in a very, very effective way. In general, if we try to learn these structures and the behaviors, okay, so we will need to learn that from some of the, for example, the systems. All right, this is the easiest way you can find some of this good designs and principles. All right, a lot of this system actually shows all the for example, how we do the hierarchies, how we enable the reuse, how we split the different modules so that they work better with better interactions. All right, so that's where you can find all these good experiences. Um, you That's where the design knowledge is hidden, right? But then in general, if we are thinking about now we're learning these experiences, we're trying to, teach you how to, become, a master with this kind of experiences, right? Obviously, there are only two ways we can find this knowledge and do that, right? First of all, the ones who wrote those systems, and they obviously have that knowledge, but the knowledge is in their heads. Okay, you can't simply like pull those. And then secondly, you can just look at the code, a source code, and then find out all the design principles. And then one good example about some of the design patterns or design things, okay, I would recommend if you got a chance, you want to learn some good things about open source project, the best project I would recommend is the Android operating system. All right. Android is written in C++ as well as Java. At upper level is mostly in Java, at lower level is mostly in C++. But either layer, you can find a lot of good, design patterns and then design ideas to learn. First of all, those are written by Google and all the great top level developers. And also the Android operating system is relatively newer than the other software. So they actually applied more good design principles than some of the software earlier. All right, so that's a very good place to learn. But think about if I gave you all the source code there, how can you learn that? Even though I told you there are certain design decisions involved and implemented, it doesn't help too much, right? So either way, it's not really good for us to learn, especially you might have a risk of losing those information. All right, so think about the principal engineer got a car accident, we're gonna lose the expert and we're gonna lose all this knowledge, right? And also, if we have the code, then how do we summarize those? All right, so these are not really good ways or good places for us to find all this valuable information and experience. So what we really need is a good way of extracting, documenting the experience so that it can be easily applied and learned and then used in some other new areas and then without too much time and efforts and risks. right? So that's kind of what the motivation of this whole design pattern, right? So we want to use the software pattern to really solve this problem so that everyone can easily learn and get that kind of experience, and also more importantly, be able to apply that, not just understand, be able to apply that to solve the new problems. So this slide summarizes what is a pattern. Okay, so it's basically talking about a solution to a common problem raised in a certain context. All right, so the pattern must solve a problem for sure, but then this is not a one-time problem. Normally, we're talking about a problem that happens again and again, and the problem happened, it has a very specific context, and then you need to provide a solution. That's why I want to learn this pattern. All right, so in different fields, you can see different kind of patterns, and then today we're mainly talking about the software design patterns. Okay, but then the previous slide I try to show you what's the point? Why do we have the design pattern? Because we want to become master. We don't know how to learn that. We can't learn that from source code. We can't learn that from other people's expert, from their head. So we got to summarize things into the pattern so that it's a very effective way, efficient way for us to use and learn. Here are some examples. If you see these different scenarios, okay, so like one good example, like for example, when you build the mobile devices, mobile apps, all right. So there were certain actual patterns. These days, people don't talk about a lot. The reason I know this very well, because back in 2010, 2012, when we were building the Android app, that was still kind of relatively early, okay? Even at that time, the mobile device already popular, but it was still early. At that time, the phone battery wasn't very good. The internet wasn't very good. The data was more expensive than today. So we got to actually follow a lot of patterns in terms of how do we build certain things, particularly for mobile devices. So for example, how often do you internet? When you are building a desktop application, when you're building a web application, you never thought about the internet usage, right? Because you assume that the computer is connected to the internet all the time. Then there is no charge in terms of how much data you use. But for mobile, it's different. That extra data will cause extra charges for the customer. So you're gonna make sure that follow certain pattern. That one good pattern is for sending some logs back to your server. So sometimes we need to collect some data logs from your device and send it back to the server. Whenever you try to do that, okay, this is something I learned from Amazon, that you always don't want to do that during the day when people are using their phone, because it's going to cost the battery. And more important, you don't want to do that with the 4G network. You only do that in the midnight if the phone is charged, and then also the phone is on Wi-Fi. That's when you can send the logs back without experiencing causing any kind of interruptions on the user experience. All right, so that's what you should do for some of this kind of situation. Another example for aerospace, I talked to some of the engineers who work on those, right? So they got a very high requirements on the real time response. So obviously for this kind of system, you can't afford any kind of delays or latencies. That's not predictable, right? So you got to make sure that this program runs within a certain period of time without being frozen, okay? Because these are mission critical real time system. So that means when they're writing the code, they want to make sure their code are following certain kind of pattern to deal with certain things. And then in certain kind of situation, you must use this structure. You must not use that kind of thing, because that will cause certain kind of memory issue potentially and slow down everything. So there are certain specific pattern to follow. And I don't have much experience on the embedded software development, so I can't give you too much concrete example. But you can imagine that writing software for deploying is going to be different from the ones you write for the desktop computer. One interesting example I do know is this, high frequency trading type of software. I had this friend. He got he got an offer from Google, but he didn't go. He turned it down. He went to Wall Street and then joined a startup company to do the high frequency trading. And obviously, people always feel that there is more chance to make more money in those kind of fields. And then this seemed to be a pretty interesting field that use the program to trade, right? So I'm pretty sure a lot of you are very passionate, or at least that one sounds very, very interesting. So I'm not too surprised that he want to join that team to do it. And then he told me something really interesting. For example, he said, well, most of the trading software, the program are written in C++ because it's faster. And that one I agree. If you want to do the high frequency trading, obviously you need to make sure everything is fast. You got a most efficient framework. And then he also mentioned something really interesting, that they actually, most of the companies try to build their server or their office closer to that, stock center. I don't know where that is. Maybe in the Times Square somewhere, right? So the NASDAQ building, I don't know where the building is. There had to be certain servers in some of this building that manage all the centralized stock price data. And then it's very interesting. He said that we want to be closer physically to that server so that our latency is also lower. That's something I didn't expect. I didn't realize that's there's a big difference, especially today with all the high speed internet. But it turned out that is a factor, right? So all the companies are trying to do that, try to move their servers to very close. So that's also a very specific pattern. Okay, if you want to deal with that kind of problem within that kind of context, and the solution is to be faster by moving your server physically closer. All right, so that's also something that specifically to that context. So very interesting. But then but I want to mention that the end story of this company is that they shut down like within a year. The startup was totally like crashed because it didn't work out. There's one week or 1 month they have too much lose, and then the investors pull their money back, and then the company was shut down. And then, but unfortunately, this guy still went back to talk to Google and then get his offer back. So he's currently in Google. I think he's in the Google News team in Mountain View right now. I haven't talked to him for a while, but that was the story. So speaking of that, guys, I want to say this one more time. For the whole stock, this kind of a high frequency trading, whatever others kind of a, this kind of trading investment thing you've seen, um, just don't do it right now. Okay. I'm really I know there are a lot of people that makes money, become rich by doing this, but then this is the game that, okay, so most people lose. All right, you don't have a good chance of winning. And don't feel that you know coding. Okay, you can write program to do trading, and then you know machine learning. You want to train some model to predict the price. Okay, theoretically, yes, you can do that, but in reality, it's very, very difficult to make money in that way. You might be able to make money, you know, 1 day, 2 days, but over the time, it's really, really challenging, much more challenging than you ever thought. Okay, doing the whole stock thing is very difficult, especially if you're doing the high frequency trading, you're doing the short term. It's so much risk that you cannot really control. Besides, in the beginning, if you don't have too much money there as your base, it's not worth the time and efforts. Okay, so that's why while you guys are young, okay, do something concrete, improve your skill, get a decent, good job, well-paid job, to learn something that's going to support your career, but also to accumulate your initial funding. And then once you have that fund, maybe then put that into the stock market. Even then, you shouldn't like to bet everything into the stock market. Okay, it's too risky. You probably only put part of it there, and especially right now, it's a very, very high, and you never know when the market will crash. It will crash for sure. It's just a matter of time. So because of that, right now my recommendation advice is just always focus on the building concrete product. Okay, skills, technologies, rather than this. Okay, it's very attractive. I agree, but just too good to be true. All right. But anyway, so like this one here, think about that guy was a PhD from Virginia Tech, very smart guy. Okay, so not his company, the startup company, all smart people. Every person feels that they're the smartest, but when it comes to here, it's all uncertainties. Okay, so too difficult, not worth the time. And last one, this one here also very interesting, also shows a pattern. This one is called a J turn. Has anyone seen this one before? So I'm talking about the turn. Okay, this one here, this kind of a road. Has anyone heard about the J turn? Do we have anyone who lived in New Jersey before? Or you have a relative there? You've been there before? You drove in New Jersey? Yeah, it's similar to that kind of ramp, but it doesn't have to be in the highway. So next time when you go to New Jersey, okay, you can still find that. You can still find that today. Not many roads. So what happened here is, think about here in California, you don't have this one. So when you're going to the road, you turn left. Okay, what we have here is normal. You got a dedicated lane here for you to stay, and then you make a left turn. Okay, that's most of the roads how the roads are working. But in New Jersey, some of the older and more historical road, okay, doesn't have to be highway. Okay, so you don't have that left turn. Okay, you had to go straight and then make this J turn and go this way here, back, and then from here, and then you join this road here. That's how you can make a left turn. All right. So yeah. So well, it exists for a reason because as I mentioned, this just mostly stays in the historical road, and the road obviously wasn't wide enough, so they can't afford of getting extra lanes. And also there are a lot of like building stuff, on two sides. You just can't really modify it. And then, but the road was built early day. That time was okay, not a lot of traffic, not a big deal. But now, you know. It's basic how they do it. But then the new road don't do this. The new road all got a wider, and then they got dedicated lane turn left. That's probably more efficient. Okay. So anyway, so yeah, yeah, Amanda. So it's not that you missed a left turn. You don't have a left turn here in some of the road. Okay. I think there is a road one in New Jersey, not California one. There in New Jersey, they also got a route one, and then you can see a lot of this kind of turn. It's very weird, I have to say. It's really weird. Sometimes you feel that you miss something and you don't know what to do. So yeah, so not very common. Only in New Jersey. So next time we go there, try it. All right. Anyway, so this example, I just want to show you that all this, different uh, problem within that specific context, and then we try to find a solution. All right. Now let's move back to the actual topic here. All right. So we are exactly what is the pattern is the better definition. Is pattern describe a problem which occurs over and over again in our environment, and then we try to describe a core of the solution in a way that you can reuse the solution again without having to do the same thing twice. So we're really talking about a very common problem. All right. And then this is the book I mentioned earlier in the class. Okay, so it's a Ghana 4 book, a very famous book. You should be able to find this copy easily. And here's the definition from the book that is design pattern systematically name, motivates, and explain a general design that addresses recursive design problem in object-oriented systems. All right. And then it try to focus on two things for the pattern. So what is the problem? What is the solution, and also like how do we do that? How do we achieve that solution? What that design looks like? How can you get the thing created? So the design pattern is independent from programming languages. All right. In the early days, the book used C++. Later on, we saw a lot of book using Java. But then if you understand that design, you can really implement in any kind of language. But mostly it's about object-oriented programming languages. If the language is not object-oriented, then you can't use some of these features. And then they give you this very like micro architecture type of thing, very concise. So like this one is something called observer pattern. This is my favorite pattern. So we'll talk about next week. And then it shows you how you can implement something to update certain things in a very uh, organized way, notifications, updates, all of this. So a lot of pattern will give you this kind of very micro type of structure so that you don't feel overwhelmed. You can see the core structure of the design so that you can figure out how to use that one in your system. Of course, when you start to use that, you can do some kind of modification based on your specific context. For example, here is one kind of a implementation of this observer pattern in Android when you are trying to do some kind of content observer. For those of you who done Android development, you probably know something called a content provider. And so if you want to watch certain content, if it be modified or not, you can try to apply this observer pattern. Also in the Android system, there is another important feature about broadcasting and notification. So if you are trying to broadcast a message, a basic example would be if you try to share something. Let's say you got an image, you click on share button, automatically it pop up all the apps that can share this photo. So you can share that with Facebook, with Instagram, share that with email, with a text message, with all the apps. You can choose which one you want to use to share that. At that time, it triggered this broadcasting mechanism, and they also use observer pattern. So we'll cover more about these details. But the same pattern, again, can be used in different contexts with some slight modifications. All right. But eventually the pattern will had to be implemented in code. All right. So code is the ultimate, the most important part. And then different languages doesn't matter. You can implement the same thing in Java, and this is how you implement it in C++. So that all okay. Also, they can be used to assist some other development approaches like agile development. Obviously, as you do the development with the team in every cycle, the design pattern will play different roles. When it comes to the design, communication, and of course writing the code. So it's a good complement. And then the same idea, when the design pattern really create a whole new kind of a topic because it's so successful. It summarizes things so concisely. It can be easily reused to solve other problems. Same problem in other different domains and contexts. Later on, people started to create other topics. Like I mentioned, Dr. Schmidt created this pattern on some different type of system, networking system, concurrency. And here's a very good book. I haven't read it yet, but it looks very interesting. It's about how you manage the software development team using the agile development. So there are some issues. How can summarize those problems and then find the right solution to solve those problems? So organizational pattern is more about the non-technical, I think a little bit more on the management side of the software development team. And this is also a pretty cool book. This book is real. I forgot a detail. It sounds like this is the same group of authors who wrote the design pattern book. They had this book called a dating design pattern. Okay, I think I remember this. I don't think this book is still available, but you can find certain things online about this book. They're literally talking about dating patterns. Okay, I think the reason they created this one because most of our CS majors, probably the guys, okay, are not really too good at dating and this kind of techniques and solving the problem in those areas. So they summarize all these problems and then create this dating design patterns. Okay, so I think everyone should Google this book after today and try to learn something from it. I think this is the real book. You can find some patterns there. All right. Anyway, so when you, again, back to the pattern, every pattern you want to learn what kind of problem we'll try to solve, what is the context, make sure the problem occurs again and again, and the teacher something, got a very concrete name. So these are the, again, same kind of items the book will present, some of the intent, what the pattern try to do, some other different name, the motivation about where you can apply that structure, participant, collaborators, all of it. These are just concepts. Okay, so we'll see some of this once we start to learn some of the patterns. All right. Why the pattern is so important? These are some good quotes from different people. It helps us to communicate. All right. So for example, we're talking about design. Okay. I told you, okay, so this part of the model, we should use observer pattern to do it. Now, if you also know what observer pattern is, then it's very easy. We don't have to explain and draw all of this, right? So it really helps us to be on the same page. Other things that I think good things, this is very good summary. Giving someone a piece of code is like giving them a fish, but giving them a pattern is like teaching them how to fish, right? So I think that kind of also summarizes the purpose of pattern. It really delivers some of this experience to you in a very effective and concise way. All right, and also it helps you to reuse. And that's also another thing we highlight in software design, because the pattern itself, we mentioned, it solves the problem again and again, and you can always reuse that. And then more importantly, the patterns are designed to help us to handle the changes. I mentioned that when we're designing software, the only way to evaluate whether it's good or not design is how well it handles the changes, right? So, but then the patterns later, you will see that different patterns tell you how to deal with those changes in different kind of a situation. Like certain patterns are deal with how do you, handle the change when you try to create different object, about creation things. Certain patterns talk about how can you deal with the changes on the dependencies, right, on the software and hardware systems. And then how do you like handle the cascading changes? And a lot of patterns are specifically solving the change problems. Others about like algorithm change. Like what if you start with one type of algorithm and then you want to do some other kind of algorithm? And then the coupling changes on all of this one. So to summarize all the patterns in the book, there are 23 different design patterns, and they're in the three categories. Certain patterns are about creation, certain about structural changes. Some of those are about behavioral changes. Okay, but all of this deals with certain kind of change. And like I mentioned, like observer, it's one thing about the behavior. So if you are observing something, trying to get some notifications about certain subject, about certain context, what if I have a new observer? What if I have a new listeners, new client that need to follow the same kind of data? Then if you use observer pattern, you will find that implementing that kind of addition is really, really easy. Right? So that's what the pattern is trying to help you. They try to help you to simplify all the potential changes. All right, all the patterns can be working together, they're related. So this is a very complicated graph. So once you learn most of the pattern, you will come back to this one and you can understand this one a little bit better. All right, of course, there are issues also with data pattern. Just keep in mind that you don't get the actual code. All right, so you still have to write the code. Learning and knowing the UML diagram, knowing the pattern doesn't mean that you can actually write the good code. So you still need a lot of practice. So that's why the pattern looks very simple, but it actually sometimes is not. Okay, implementing that may take you a lot of efforts. All right, and then that's why it involves a lot of human intensive activity. You got to write the code, get the code done by the developers. Sometimes this one happens, when you just start to learn pattern, we tend to overload the use of patterns. And sometimes once you learn pattern, you start to realize, oh, wow, the pattern is so powerful, so good. But then you start to use that in every single case. That's also kind of not good. So don't look at all the problems as a nail. All right, so really be careful when you're using all of this. And then finally, some of the lessons I want to highlight that you want to apply the pattern successfully. Make sure you do have a good broad knowledge of patterns for the domain. Okay, knowing that problem domain, the context is really important because that helps you to judge and decide which pattern to use. So different kind of domain, different like languages. There's so many things going on. Just so the more you know, the better you can decide which one is your best choice. And you will face a lot of decisions. Sometimes the same problem looks like you can have multiple solutions. You can apply multiple different patterns. There's very rarely there's a perfect solution. So you will need to evaluate the trade-offs and see which one is better. All right. So like sometimes you got this kind of a template method pattern and the strategy pattern. Both of those can be used to deal with the changes in algorithm, but then it depends on your actual system, the existing structure. Maybe one pattern will be more better than the other, right? And then also this is the example I mentioned. For the same pattern, you might need modifications depending on the context. They may look different. Also, that requires your knowledge about the pattern, about the problem the pattern can be solved, and then also the specific system you have, right? Yeah. So anyway, so this is the kind of a typical way to use the pattern. So you need to learn the pattern. That's what we're trying to do right now. And then once you know all of those, you should start to kind of apply And then when you are apply, try to know the trade-offs to make the right decision, and then try to implement it, and then eventually, get all the code working, then go back and forth to do all these iterations. All right. So yeah, so the last advice is just don't brand everything as a, software pattern, because this one happens very frequently when you just start to learn design pattern. After a few patterns, you start to see, oh wow, I got a lot of good experience I can reuse, and you start to apply that in every single case. So not every problem can be solved with the pattern. At least you should know the right context. All right. So these are some of the references. I'll put that in the Blackboard. But then here is just a very quick overview about software patterns. And then from Thursday, we'll go through those patterns one by one, and then try to start to do more kind of concrete examples with those patterns. All right. Okay, so that's kind of what I want to share today. Any questions? Oh yeah, so Jimmy is asking the remote work. Right. It should be fun. I mean, it won't affect too much in terms of learning. And I can tell you where you can learn most. Okay. We haven't covered this one in 4D class. In my opinion, you improve most by two things in the company. One is when you do the code reviews. So in the big companies, every time you submit, you make a change. Before you push it to the repository, you need to submit a code review. And then your peer developers, your teammates, will look at your code and make comments. Sometimes it's one person, sometimes they require two code reviews just to be more serious. They don't run your code. They just look at the changes you made because they assume that you already tested everything, the function is right. They're just commenting on the design, on some of the best practice, the principle, all of those. They comment those, so they may agree or not. So if you say something to improve, then you got to fix those until they approve the code and then check a button. Okay, go ahead to push it. They call it ship it, right? And then whenever you go to the comment, you got to go back to fix them and then resubmit to address their issues and comments. That's the part I think you will learn and improve most. Okay, because you directly get those experiences and suggestions from this experienced developers, and then you will start to see that the first code review is going to take weeks, sometimes 1 or 2 weeks to finish. Later on, you can do better and better. You know what they're going to pick, and then you can just handle that quickly. That's when you really improved. So because of that, I don't think that's going to be affect too much, whether you work remote or not. It's still kind of the same thing. They will just put some comments and using the tools. Number two is that you are going to access all this code that's people already have finished. And then from there, you will see really good ways of they code things. And that's, for example, today you have a task to add this new feature. And that's when you need to read this part of the code base and then follow their style to add something new. And then you will find, oh, actually, they're actually writing things in this way. And I'm also going to copy their approach to do it. In the beginning, you're mostly only modifying their code. And later on, you can independently creating your code. So that's how you can really change the way you write a code. But anyway, your improvement happens when you are doing the code changes by learning from the better ones. If you only write things by yourself, you can improve, but very slowly. But by seeing some other better code and getting their feedback is more effective. Yeah. So good question, Rafi, about software testing. Okay, we're talking about this one in software engineering course. It's actually the skill that's most underrated in colleges, but it's actually yeah. So in reality, when you start to work, for those of you who have done the work in the companies, and you know how important software testing is. Basically, most of the companies they require you to test every single thing you write. Uh, when we're talking about testing, we're not saying that you run your code in Eclipse and then test it manually, right? So we're saying that you test it automatically using some kind of a test framework. So as a developer, you just need to be master of all the unit test frameworks. So for example, if you use Java, you need to know how to do the JUnit. All right, so this is the most famous unit testing framework. It's very easy, okay? Just to take a look at some of the tutorial, you will learn that. So when you do Java, you have to write the unit test for every single thing you code. And any kind of language, you can have it. For example, for Python, if you Google unit test, there must be some kind of libraries that's available for you to do. Okay, this is how you write a test. Any language has unit test framework. That's what you should focus on right now in college. At least given a master function, given a class, how can you write a unit test for it? How can you unit test all the public methods? That's the most important skill you should have right now. In the team, um, you know, uh, very often the task you'll be given, it shouldn't be too difficult in the beginning. But the really challenge comes from that requirement on the test, because sometimes you will find that your code is not testable, and you want to call it from here, but you cannot, or you want to call this function, but this function relies on a lot of other things that you cannot really create in a test environment. So there are so many different experiences and approaches you can apply to get the test done. That all require experiences. And then that's also another good thing you can learn very quickly in the company. But in the university, in colleges, we give assignment, everything. We never really ask you to do unit tests, all of those. So, but just keep in mind that's a very important skill. But back to your question, Rafi, what you should prepare is just to know how the unit test works and pick one or two unit test framework to be really good at it. Okay, whether it's JUnit or if you're doing more C++, C++ also has a unit testing framework, or if you do more Python, just take a look at how Python does the unit test. At least you know the basic. This one is not too much stuff. Okay, you probably need half day to learn the unit testing. But at least you need to be ready when you start to work, and then you know immediately what you should do for the unit testing.